So we talked yesterday on how we got to this solution or arrived at this solution. Again, this solution came over many years. As this slide showed, we originally started out with falling down and crawling because we didn't really have a good capacity planning practice in place. So when things broke, we fixed it, but we really didn't want to continue that way. And I'm sure a lot of companies and a lot of folks started out that way. You know, you write some code and hopefully it works, and when it doesn't, you deal. And we moved along the circle to actually becoming more proactive, building capacity planning models. And again, our organization is capacity planning as well as performance management with a focus on capacity planning, so long-term predictions. So we started building models in Excel, and Excel was time-consuming. It was a lot of work. We had to pull the data manually in a lot of cases. There wasn't any automation. We went to vendor or proprietary software. That worked, but it was an issue for several reasons. Price was a problem. Features were an issue. We couldn't get the software to build the models that we wanted or to adapt to the different hardware and software packages that we had loaded. So then we finally decided, okay, we're going to look at an open software stacks. All right, and we built the open software stack that we felt was very flexible, extensible, point and click for our users. And again, this is really important to us, and it's one of the reasons we went to a graphite Grafana, is we wanted to allow our end users to basically point click, not have to understand the math, and be able to apply statistical functions to the data. And we also wanted to store raw data indefinitely. A lot of our packages, and I'm sure some of the tools that people here use, summarize data. If you use Ganglia, it summarizes the data. SiteScope is another monitoring tool we use. It summarizes the data. Our Splunk summarizes the data, and we roll data off. We don't keep data indefinitely. Even though we can back it up to Hadoop, it becomes very expensive for us. So we have a limit on retention. And because of that, we needed another method to keep the raw data, because you really can't do capacity planning on summarized data. Once you summarize the data, the samples get rolled off, so you're really working with a flat number, and you can't build any models with that. So again, we wanted to store all the raw data. All right, so we built this stack, and we talked about this yesterday, with Grafana, Graphite, OpenTSDB, T-Collector, and HBase. Graphite we use as a pass-through. We really don't use any of the Graphite functionality except the statistical processes that are found in functions.py. So if anyone's familiar in functions.py, you can basically code anything you want. We've expanded that, and I was happy to hear that the next version of Graphite also has the linear regression. We put the linear regression in, and we put in clustering, and we're probably going to, next thing is either a logistic regression or correlation, but we can see where that goes. But we're going to put more stats in it. But again, it is a pass-through. It's point and click. Our OpenTSDB is the database we chose. At the time we chose it, it was the one that would provide us the most scalability and could ingest the number of metrics that we wanted to store. We were also looking for a collector, a scheduler. T-Collector was available, very simple to use, and we'll go through that in a bit. But it's very easy to use, and to get data, all we needed to do is write an adapter, and I think we have about 58 adapters, and the adapters will go out to our endpoints, SiteScope, Splunk, vCenter. So we pulled data from vCenter with over 30,000 VMs in our vCenters. And I think there's 12, 13 vCenters that we support. We pull all that data every 5 minutes because that's the lowest level of granularity that we're able to store in our vCenter. And then we have our HBase sitting there. The environment, the architecture is relatively simple. It's Grafana Graphite sitting on one big old box. OpenTSDB, the T collectors, the ADP adapters that we've written ourselves, sitting on another box, and that's the scheduler, and then there's our Hadoop cluster. Now, everyone has seen this. This is just a sample of our dashboards. It's just one of them. And as you can see, it's nothing that anyone else hasn't written. We do have the templates we pulled out for our servers. We do CPU, memory. We do login forecasting with the regression tool. So it's very similar dashboards. Shouldn't be a surprise. What I did want to show you is some of the regression that we do. So this is the linear regression tool on our login. So we're basically being able to project where our login trends are going. Now, this really isn't a good regression. We have the spikes in it. It's not a typical step up that you would normally see. We can do a regression on smaller time periods, and we do. It's extremely helpful, and if you have Graphite, probably the 1.0 version is going to be great to help you with trending regression. You can push this out, and we'll take a look if we have time. But you can push this out to actually see what your 30-day, 60-day period will look like, because with the regression, it can extend. If you extend the end date, it'll extend the regression point, so it'll project the line. Now, what we've put in is we've put in some of the adapters from Grafana, and this is one of the histograms. So instead of the straight graph panel, we've also used the histogram panel, a heat map, and the pie charts. So with the histogram panel, you can see that's the same login information that we get, and that's if it's plotted normally. When we plot it with our clustering, you can see over here that we plotted it with 3 clusters. It's a k-means clustering setup. And this tells us primarily where the bulk of our logins are occurring and what range. So we're in the 25 to 50 logins per second, where it's when you look at the original chart, it's a little more difficult to understand what you should be focusing on. So the clustering allows us to get a better idea of where the bulk of our logins are. So the green one is where we would focus on. And then when we start seeing yellows or we start seeing blues, we know there's some sort of issue. Now that could be a problem with a network backing up, servers backing up. It could just be a busy day, and we do get busy days all the time. But this has helped us understand what normal is and when we exceed normal. All right, high and low, right? Because normal high could be bad, normal low could be really bad. So the k-means clustering has helped us quite a bit. The trending is another example of the trending that we use, and this one helps us project disk storage and when we're going to need to add more disk storage. Again, this is capacity planning. So we want to add storage to our key databases, and we use the linear trend to pull in this information, trend out, and say, okay, I see what my used is as the yellow, I see what my allocated is yellow, used is orange, and now when should I add more so I don't crumble and fall into the sea? Because if I run out of disk space on my database, bad things happen, right? So we do use these functions quite a bit to help us get a better understanding of our environment and when we should add more, when we should build more servers, when we're having issues. So we don't just use Graphite to plot data. We actually want to use the analytics that are inside of Graphite. People familiar with Graphite, these are all the functions that Graphite has available to it. Another one that's interesting is the Holt Winters. That was there in 0.9. That's really interesting if you're trying to do some plotting for seasonality trends. That'll help you there. But there's all types of different functions that you can apply to help you better understand the data. And one of the reasons we chose Graphite is it had those functions. Had the functions written, we didn't have to incorporate or write them all ourselves. And it was at the time when we started difficult, if not impossible, to really incorporate all of those right into Grafana itself. We probably could have done something, but It was just easier to use graphite at the time. The other thing I wanted to point out is any function that, we'll go back for a second, any function that you incorporate, you notice this is Grafana, so the k-means and the linear regression are actually in the pull-downs. So all you need to do if you decide to use this approach with your graphite is you update your graphite with whatever function you want in functions.py, you add it to its pull-down list, and then you go into Grafana in, I think it's gsum.js. It's another module, and then you just add that to the pull-down. I mean, if anyone's interested, I can give you the details. Just shoot me an email. And then you can just do point and click. If you don't want to add it here, then you can still do the pull-down function, but it's really up to you. You can edit the line. Do you guys from Grafana, do you remember the name of the function? No. Okay. Now I don't feel so bad. All right. So let's talk a little bit about OpenTSDB. OpenTSDB was a really simple, concise data model, and we thought it explained the data very well, at least for us. The way the data model basically functioned is it's a metric, a timestamp, a value, and tags. We felt that our data in the 5 tags could pretty much be described completely. So these are the tags we chose: source, a host, a processing center, an application, and then another tag. These tags are all overloadable, if you will, if that's a word. So source can be anything, right? The value, the name value pairs doesn't matter, all right? It's just a hierarchy. The hierarchy is defined in the TSDB tree, and we'll talk about the tables. In OpenTSDB, there are 4 tables. The two important ones for this discussion are the TSDB table, which stores all the raw metrics, and the TSDB tree, which describes the hierarchy of how you're going to view your data and do pull downs. So I'm going to show you on the screen when we do pull down. Let's see if we can go back a second. When you do a pull down, it defines, like, the BMC would be a source, DC would be our data center, repo 1 would be maybe a type. So it defines the hierarchy of the pull downs that we're going to see in Grafana. All right. So this information, this hierarchy, gets defined in the TSDB tree. All right. And then you tell Graphite you want to use the particular tree. So you can have multiple trees and multiple definitions of how you want to view your data in a hierarchy. You can have tree 1 that has a hierarchy in this order. You can have tree 2 that has a hierarchy with 10 other tags. Now the limitation in that is for each tag you have to run a different Apache server, because that's where it flows through, and that particular Apache server knows you're using tree 1 or tree 2 with a different hierarchy. Other than that, you can have as many hierarchies you want and define the data any way you want in the same tree. So that's our data model for our metrics. And the adapters really follow that data model. And these are the adapters that we have. We have vCenter. You got data from vCenter, data from OEM, data from Splunk, data from BSM, Wiley, BMC, NetApp, SiteScope, Z-Linux, if any folks have Z-Linux in their house, in their organization. My condolences to you as well as to myself, but and we're writing more adapters. And again, some of these that you'll see here, you'll see a Splunk adapter. And you say, well, why are you doing this? And why are you writing a Splunk adapter? Right? And there's really a couple of reasons for that. We're writing a Splunk adapter. First, we don't store all the data. And second, a lot of users of our system don't want to program Splunk dashboards. They don't want to write Splunk queries. We were having a conversation before. Why would you do this, right? Because our people, our users don't write queries. So if you have end users that aren't technically sophisticated, can't expect them to write a Splunk dashboard. I don't know how many folks have written Splunk dashboards. All right, not that difficult, but if you don't have to do it, do you want to? No, right? And it's much easier to do a pull down, right? So what we do is we write the Splunk queries, we put it into our database, and the data can just be pulled down, and everyone takes a look at it, and they can do their analysis, and it's just a lot easier for people to use and view the data and visualize it than having to spend a whole lot of time writing these queries. So we have quite a few adapters, and we wanted a scheduler that ran the adapters for us. We didn't want to set up a cron and build a whole other system, which we could have, obviously, but OpenTSDB had something called T-Collector. So again, if anyone's interested in OpenTSDB, and even if you're not, you might want to take a look at T-Collector if you have any adapters that you schedule or anything you want to actually run at a predefined time frame. So our adapters, T-Collector has a set of directories by number. So 300 directory runs anything in it every 5 minutes, 600 every 10 minutes, and so on. So our adapters are simply code in Python, Java. We actually have R code, if you can believe that, and we run R for some of our adapters, and we use R for some analysis as well. And there is a Go language code too, adapter too, and I'll show you that in a few minutes. But we have all the adapters loaded in the T-Collector directories. They run automatically, and they pull out data. The T-Collector basically writes the data in the OpenTSDB format, which is metric name, timestamp value, tag equal value, etc. And then it just pushes it to our HBase. So we have a 3-node Zookeeper and a 12-node Hadoop on the back end. Now it's shared, and it's not all ours, but that's the environment. The adapters, whenever the adapters run, they simply spool the data to standard out. The T-Collector prefixes the string that we pass with a put and pushes that into OpenTSDB. So again, it's really simple. It's really clean and easy to get up and running. You can probably take a T-Collector, load it on a machine if you wanted to, in about 5 minutes getting it to run, if it even takes that long. Okay. So there's 4 HBase tables. We have 6,258,000, I'm not going to go through the others, aggregated raw, non-aggregated data series. It's actually 200 gigabytes last time compressed LZO. It's really small, and we save a lot of space doing this. Our Splunk installation is multiple terabytes, and we only store data there for maybe 30 to 60 days, depending on application. So the compression is just phenomenal on what we can do with this. 58 unique adapters going after just about every data point that we have in our systems. Just for grins and giggles, we'll take a look at some code. So this, and again, if anyone wants this, give me a shout. We can share this. There's nothing proprietary about any of this. But this is to pull data directly from the Splunk API. If anyone hasn't actually done that, if your security boys and girls allow you access to the API, this is just Python code. You establish a session. We have multiple URLs into it, so I've cleaned this down substantially, but you establish a session, you actually run your Splunk query. So if you know how to write Splunk queries, that's basically all you need to do over here. So write your Splunk query, submit the query, you get back an ID from Splunk. And then here's the bad part. You have to poll it. You have to pull it because it may run quickly, it may not run quickly, but you poll, and when it's done, then you simply retrieve the results, and then you write whatever code you need to put it in that OpenTSDB format, and it loads in again really quickly. And the first chart, if you can think back, the login, the WFN login screen that we had that I showed you as a simple graph, as well as linear trend and clustered. That's all coming from Splunk. So the other one we're working on is Go. So this is and I'll show you this as well. This is Go code that's actually going into UCP of a swarm, and it's actually pulling out all the containers that are running. It's recalculating the CPU time and giving it to you in terms of a percent, and the data would actually appear like this. So it's CPU usage, date and time, percent, and then the container. All right, so we can pull all that information out. Now, will we use this ongoing? Not quite sure yet. This is something we're experimenting with on how to pull data out of our Docker infrastructure. Again, we have an issue with loading agents, so this way we don't have to load an agent. If you go back to that big picture we had, I can put this adapter on one of my big boxes, and then it can go to all of my UCPs. All right. So this is another sample of what you can do with the product. This is, again, our code. This code drills right into OpenTSDB. Again, you can write any metric you want, pull that data right into R for further data analysis. I'm not sure how many people actually use R, but it's kind of a fun language to play with. But this goes right in, builds a data frame similar to a Python data frame, and once you have a data frame, we can do anything you want, and this will go right into OpenTSDB. Graphs that we kind of built with them, these are just samples. This is a spider clustering. Box charts are really kind of interesting because it helped us understand the difference between response times from one of our key data centers to the other. All right, and it turned out to be a very simple reason. It's a network delay. One's coming from one location, one's coming from 1,000 miles away. So there's a little bit of a delay. ARIMA models is something that ARIMA models were forecasts. We were using that to build into MAR. So again, once you have the data, there's plenty you can do in terms of the analysis and the statistics that you want to apply to it. So that's kind of what we've built. Now I'll show you a couple of things, and then we can stop. In this screen, and I just want to show you real quick. In this screen, we're collecting. There's another linear regression that you saw. There's the clustering that we saw. This is collecting CPU metrics from individual VMs, and then this one over here is showing it to you in a pie chart, which we've downloaded from Grafana.net. Now the k-means piece, again, if you want to do, if you look over here, this linear trend doesn't tell you a whole lot, so that's why we went to the k-means. And the k-means is really simple, and once you incorporate all the information into Grafana and hook it back into Graphite, using these algorithms are rather simple, right? With this, I mean, you can change the clustering, very simple, and now you can, if you needed to see more clusters and see if there's a different grouping that you should be interested in, it's rather easy to do with this kind of approach. Like I said, this is CPU data and information that we're getting. Obviously, it's not as sophisticated as the Snap presentation, but we're getting data basically the same place that they're getting their Unix information, which is /proc. So we're pulling all kinds of data from /proc. We have CPU information, we have process information. And the thing I wanted to show you on this one is we are getting process information, and it's part of the template. So if you go into /proc, you can actually pull down all your processes, all right, pick whichever one you want to see. and then it'll display them over here in whatever graph you want. And then this one here, as you can see, a high usage process is from stats directory. So you can see which one is being really piggy. All right, so that's Java. So it's coming from OpenTSDB server. This is just the actual string of what I put in to do the pull downs, and that's how many seconds it's accumulated since it started to run. So you can you can get all that kind of information as well. It's kind of neat to be able to do all that. One more, and then I'll stop. This is going to take a while to kind of boot. Again, it's not as sophisticated as the snap, but this is going into the UCP and it's pulling out Docker information. In this example, once it starts, this is all the container information that we're going to have, and it's going to calculate the CPU percent utilization. As you saw in the code, it needs to take the differences between one and the other. It's kind of slow because it's running on my test server. Everything's running on one. But this is actually going across the network from that box across to our infrastructure, going into a test container. So we're experimenting with pulling data down. Now this just says CPU, but once you have access, you can pull in CPU, memory, network, IOs, IOPS, anything. There's hundreds of metrics that are available from the API on Docker. So these are some of the things that we're experimenting with, some of the things that we're actually have implemented, and we're still working on more adapters for ourselves. And again, we like the adapter concept because if we need something, we write an adapter, we put it in, and we move in our database. So that's kind of our story, and that's kind of our journey, and I'm done. Thank you.